Hi everyone. Today we're going to be doing assignment 7 question 1, which is permutations. So the question is in how many ways can the letters in Bananarama be arranged if the 5 A's must be together and the B and M cannot be together? So let's recall that in Bananarama there are 10 letters. So we can write that down, and let's make a legend to keep track of each letter. So we have 5 A's, 2 N's, 1 B, 1 R, and 1 M. So let's focus on the A's and the N's for now, just because they are the most letters in the word. So A's are one of a kind, but they are all the same letter and they represent the same thing. The question is asking us to keep all the A's together. So what should we do? Well, I think that we should treat the letter A as one letter. So N's are also one of a kind, but they too are the same letter and they represent the same thing. However, they are a little different than the A's. So feel free to pause the video and grapple with this question why. I'm going to scroll down and answer it really quick. N's are different because the problem does not ask us to keep them together. Therefore, we do not have to treat the N as one letter. Instead, we will account for the N's in our problem by always dividing our numbers by 2 factorial, because there are 2 N's that don't have to stay beside each other. Always make sure you're accounting for your letters. So this is how I came up with how many possible ways A can be represented beside each other in the word. Through trial and error, I determined that there are 6 ways. I put the A at the beginning of the word and I put it at the end of the word, and I came up with 6. Hopefully you guys all got something the same. Since we're treating A as one letter and we're using permutations, which means an ordered sequence of objects like the A's we're dealing with to determine how many ways Bananarama can be arranged with different rules, we do have to use m factorial. That is part of the permutations unit. Therefore, our answer of 6 is going to become 6 factorial. This is not the end, though. Remember that we must account for our n's too. 2 n's become 2 factorial, which I already said above. So let's determine this. So 6 factorial divided by 2 factorial is 6 times 5 times 4 times 3 times 2 times 1. We're going to divide this by 2 and 1, which is 2 factorial. These cancel each other out. We have this left right here. 6 and 5 we know is 30. 30 times 4, well, we know that 4 times 0 is 0 and 4 times 3 is 12. We do have to account for the 3 still, so 120 by 3. Well, we know from cross multiplication that 3 times 0 is 0, 3 times 2 is 6, and 3 times 1 is 3. So there are 360 ways that the A can be represented beside each other in our question, in our word. Step 2 is dealing with B and M, which can't be together. So let's remember that there are 2 ways we can't let B and M rest beside each other, BM and NB. Let's treat this problem like B and M must stand together. However, this is a little bit simpler for now. We have 5 spots left for the letters B and M. We have 5 spots left for the letters, and B and M must stand together. That gives us 5 factorial for the spots left and 2 factorial for B and M. Remember, we have to account for the 2 n's that are the same that we have left. That's why our formula final equation should be 5 factorial divided by 2 factorial times 2. We're multiplying that 2 back into the equation to make sure that we account for both cases with B and M, which are MB and BM. So let's go ahead and do this. 5 factorial is 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 2. We can cross this out. Now we have 5 times 4 times 3 left. We have to make sure we add the 2 left in there. So 5 times 4 is 20. We know that 3 times 2 is 6. So we can cross multiply. 6 times 0 is 0, and 6 times 2 is 12. Therefore, there are 120 ways that B and M can rest beside each other in the word. Perfect. So now we have our 2 final numbers, 360 and 120. We need to remember that we're determining that B and M cannot stand together. We've already determined the ways that they can stand together. Therefore, we have to subtract 120 by 360 to get our final answer. So let's do this. 360 minus 120. 0 minus 0 is 0. 6 minus 2 is 4. And 3 minus 1 is 2. Awesome. So your final answer should be 240. There are 240 ways the letters in Bananarama can be arranged if the 5 A's must be together and the B and M cannot stand together.